Today we'll be talking about reading and interpreting data, a skill you would definitely need if you're working with scientific experiments, business management, financial planning, or even social science research. Statistics is all about numbers, and numbers can make you dizzy, particularly if you're dealing with big data. So we look at some nice and easy examples in which we see numbers as digits, or we see them in hundreds, or in thousands, or even in percentages. So bear with me and let's see how we go. For example, this first graph in front of you represents the outcomes of a city election. You see a graph that is called a bar graph. The x-axis of the graph represents people in different age groups and genders. The y-axis has two sides. The left side represents number of people who took part in the election. The right side represents percentages of people, and the bars in between, they have three different colors. The purple color represents the number of people. So for example, in the first set of bars, the purple bar represents the number 1045, which is the total number of people who took part in the election. So it is the number of people. While the blue bar represents the percentage of people who approved the election. And the yellow bar represents the percentage of people who disapproved the election. So the number 40 and 60, they are percentage. However, the number 1045, it's just the number. Similarly, the next set of bars up to 65 plus represents age group. And age groups are, for all these age groups, there are three sets of bars as before: purple, blue, and yellow. And the last two sets of bars represent genders. And again, the colors are the same, representing the same thing. So for example, in the male set of bars, there were 478 males who took part in the election. 44% approved and 56% did not approve. Now the first question is what the number 40 means in the graph. And you might want to go back to the graph and see what the number 40 means. Okay, in the graph, we see that the number 40 is coming up in the first set of bars, which represents the total sample and the percentages of people who approved or disapproved it. And you see that the 40% of the sample approved the elections. Okay, so the answer to the question would be 40% in the first phrase. 40% of the sample approve of Mayor Ford's actions in office, which looks true. So we put a tick here. And we also look at the other four options to see why they are not true. In the second option, it says 40 people in the sample approve of Mayor Ford's actions in office, which is not true. The number only represents the percentage, not the number of people. In the third phrase, it says 40 people in the sample. Again, it's starting with the wrong argument, so we just disapprove it. In the fourth phrase, it says 40% of the sample disapprove of Mayor Ford's actions in office, which is not true because 40% approved it. And in the fifth phrase, it says 40% of the population approve of Mayor Ford's actions in office, which is totally untrue because we are only talking about the percentage from the sample, not from the population. Okay, in part B, we have to identify the complement of the phrase in part A. And the phrase in part A is 40% of the sample approve of Mayor Ford's actions in office. So its complement should be that 60% disapproved of actions, which is represented in part B by the second phrase, I guess. 60% of the sample disapprove of Mayor Ford's actions in office. So this is our answer. Now part C asks about what the entry 30 means. And if you look at the graph, then the entry 30 appears in the age group of 18 to 34 years. And it represents the percentage that approves the elections. So out of the 5 choices that we have, we see that the second choice says 30% of the 18 to 34 age group sampled approve of Mayor Ford's actions in office, and that should be the correct one. In part D, out of the males and females, what percent are males? Now, if you look at the second last set of bars, then the number of males are 478 out of 1045. So if you divide 478 by 1045 and times it with 100, it turns out to be 46%. And in part E, out of the females, what percent disapprove of male food? Then you see that in the last set of bars that represent females, the percentage that disapproves is the yellow one, which is 63%. It says that you should write the exact answer, but it's all right. You can write it in percentage, so you can round it off. Part F asks you to look at all age groups, which is represented by the first set of bars, and tell what percent disapproves of male food. And we know that the yellow bars represent the disapproval, so the answer should be 60% straight away. In part G, you have to find the probability that the elections are approved given that the response is coming from males. Now, since the graph already is representing the set of bars from males, we know that there are 56% of males who did not approve the elections. So the exact answer, which we have to write as a fraction or a decimal, should be 0.56. Sorry, we have to look at the approval. So this should be 0.44. In part H, we have to look at the age groups and those who are more than 44 years old, which is represented by three sets of graphs: 44 to 54, 45 to 54, 56 to 64, and 65 plus, and add all the numbers who took part from these age groups, and we know that they are represented by the purple bars. So we add all the numbers against the purple bars and divide them by the total number, which is 1045, to get the percentage, and to me it comes out to be 79%. And in part I, we have to find the probability that the elections are approved by the people of age bigger than or equal to 65, and we see that the set of bars that represent 65 plus has the approval rate of 48%. So the probability should be 0.48. Now let's look at a different example, which we call example 2, in which the data is not given in terms of a graph, but it's given just in between the lines, and we have to extract the information from the expression of the question. So it's given that we are studying the case study of a city where people have got AIDS, and the total number of people who've got AIDS, let's call it P, is 3059. Now I give you just a minute to read the expression. Now you can see that some cases are given as having obtained the disease through heterosexual contact, and they are 6.4%. We call those cases as H cases, and their percentage is 6.4. Then there are some cases that are considered as just the female cases. We call them F, and they are 7.4%. And out of the females with the disease, 53.3% got it from heterosexual contact. So let's call that category as F sub H, and that is 53.3%. Okay, so in this way the whole population is divided into three categories. And the first question asks us to find the probability that the person, if we select it from the population, then that selected person is a female, and that's only possible if the person is selected from the female population, which is 7.4% of the whole population. And a very important thing to consider in this case is we are considering the whole population as 100% because the categories are given in percentages. So we will consider the population also in percentage. So no matter what the number of population is, it is considered as 100%, out of which 7.4% are females. So the probability must be 0.074 dividing 7.4 by 100. In the second question, we have to find the probability that the person is picked from the group of heterosexual contact, and which means that the group which is 6.4% of the total must be the group where the person is picked. And so the probability should be all the people that got the disease from heterosexual contact divided by the total number of people, which is 6.4 divided by 100, which is 0.064. In part C, we find the probability that the person selected is a female, given that she got the disease from heterosexual contact. So in this case, she needs to be from the group of FH, which is 0.533 as before. On this slide, we see the information we obtained already, and we can see that this information is expressed in Venn diagrams, where the circles represent two data sets, F and H, and the number that intersects the circle represents the probability of the intersection. And there are 5 options given to us, and we have to pick the right option. And we can see that the information we have obtained is expressed in the second option, where F is 0.074, the probability, and the probability of H is 0.064, and the probability of their intersection is 0.533. In the third example, we have data represented in a table, while in the first example we had it in the form of a graph, and in the second example we had it in words, and we extracted information from there. Now in this example, we have all the information given in the form of a table, and we see that in the table the first column represents the categories of the data we have, which is males and females, and also the total. And in the second column, the data is about males and females who learned music by themselves. In the third column, we have the numbers of males and females who studied in a school. In the fourth column, we have those people who learned music through private tuition. And the last column represents the totals of females, the totals of males, and the total of both males and females. Similarly, we can read this table row-wise. So the first row is just representing the categories of musicians who learned by themselves, or who studied at school, or who studied private instruction. So in the second row, you see that this data is expressed about females, while in the third row the data is expressed about males, and in the third row this data represents the total number of males and females who are self-taught or studied in school or had private tuition. Okay, in the questions part A, we have to find the probability that the musician is a female. Okay, if the musician is a female, there are no other conditions, so we have to include all types of female musicians, whether they are self-taught, or they studied in school, or they had private instruction. In statistics, when we use this word "or," then it simply means addition of all categories. So we add all the categories of females to get the total of females, which is already given to us as 68, while the total number of participants in the survey are both males and females, which is 133. So if we divide 68 by 133, we get the number 0.511, which is the probability that a musician is a female. And similarly, in part B, we have to find the probability that the musician is a male and had private instruction. So we have to choose the row that represents males and the column that represents private instruction. And we see that the number at the intersection of the row that represents male and the column that represents private instruction is 15. So if we divide 15 by the total number of males and females, that is 133, and 15 divided by 133 gives me the number 0.112. In part C, we have to find the probability that the musician is a female or they are self-taught. Okay, in that case, we see the word or between them, and we already said that if there is an option between the two events to occur, then their probability is equal to the sum of their probabilities as independent events. Okay, so we have to find the probability that the musician is a female and also the probability that the musician is self-taught and add them. So from the previous slide, we see that the probability that the musician is a female is 0.511. So we write probability that the musician is a female is 0.511, and the probability that the musician is self-taught will be the total number of musicians that are self-taught, which is given to be 35, divided by the total number, which is 133, and we get this as 0.263. So the probability that the musician is self-taught will be 0.263. And if we add those numbers, it turns out to be 0.774. So the probability that the musician is either a female or is self-taught would be 0.774. And in part D, we just answer the event that the musician is a female and that the musician is studying in school. They are mutually exclusive events which means that they have nothing to do with each other, which is not true, obviously, because if the musician is a female, they can study music in school. So the answer would be no. And now we are looking at another example of data interpretation, which comes from a tree diagram. While in the previous two examples, we followed information from a graph and then from the expression of a question, and then also from a table. So we did 3 examples, and in this example, we'll be extracting data from a tree diagram which shows the tossing of an unfair coin. So that's very important to understand in the first place, that the coin tossed is an unfair coin. So we cannot say that there are only 2 possibilities, a head and a tail, and both head and tail will have probabilities different from a half that is usually taken. And also the tossing of the coin will be followed by drawing a bead from a cup that contains 3 red balls, 4 yellow balls, and 5 blue balls. And for the coin, the probability of getting a head is 2 by 3, the probability of getting a tail is 1 by 3, which is expressed in the tree diagram, and in 2 different colors. And also we see that since there are 12 beads or balls in the cup, the probability of getting a red cup, since there are 3 red ball, the probability would be 3 out of 12. And then the probability of getting a yellow ball would be 4 out of 12, since there are 4 balls, and the probability of getting 5 balls, blue balls, is 5 out of 12. And the same expression follows for the tail after obtaining the tail of the coin. So we toss the coin and we pick a ball. That's what's happening. And there are 1, 2, 3, 4, 5, 6 events occurring. And in part A, we have to answer the question that if we want to find the probability that tossing a head is followed by picking a yellow bead, then how should we obtain it? So first of all, we look at the direction of the probability in the tree diagram. So we toss a head, which means we are going in this direction. And then we pick a yellow bead, so we are going in this direction. Okay. And also the requirement is to find the probability of tossing a head and a yellow bead. Now the word "and" in statistics refers to multiplication of probabilities of either side. So the probability of tossing a head, which is 2 by 3, and the probability of picking a yellow bead, which is 4 by 12, which can also be written as 2 by 3 times 1 by 3 for simplicity, and that comes out to be 2 over 9. And that's in fraction. So the answer could be in fraction, or it could be in decimals. You can find by dividing 2 by 9. So that was the probability of tossing a head on the coin, and when it follows by a yellow bead. Finally, we answer a couple of questions here. In part A, we have to find the probability of tossing a head followed by picking a yellow bead, and you see that there's a word and between tossing a head and picking a yellow bead, which means we have to find the intersection of tossing a head with a yellow bead. We have already answered this in the previous slide. So we see that the probability of getting a head and a yellow bead is 2 by 9, and if we multiply both top and bottom by 4, we obtain 8 on 36, which is the first choice here. Okay, in part B, we have to find the probability of getting a red bead. Now, if we go back to the tree diagram, we see that a red bead can be chosen with a head or with a tail. And again, there's a word or, so we have to add the probabilities of getting a red bead with obtaining a head, and getting a red bead obtaining a tail. So in this case, we find the probability of getting a head intersection with R, and we add it with the probability of obtaining a tail with a red bead, and this gives us 2 by 3 times probability of getting an R, which is 3 by 12, and then the probability of obtaining a tail was 1 by 3, and this is times with 3 by 12. We know that when there are intersections and intersections are independent of each other, then we always multiply the probabilities. So this is the one set of multiplication and this is the other set of multiplication, and we see that this turns out to be 2 on 12 plus 1 on 12, which is 3 on 12, and if we find the equivalent of this in the 4 choices, then we see that if we times both top and bottom by 3, then we get 9 over 36. So this is an equivalent answer.